People don't come into VR training with a blank slate. They bring with them specific expectations or mental models of how things should work based on all of their past experiences. For example, in different game genres, like platformers versus RPGs, you expect certain mechanics and controls and behaviors. There are expectations in visual language, and those mental models from game design directly carry over into VR. And then when those patterns keep changing, like it did in the example from the last video, it causes friction or confusion or cognitive overload. And that, of course, in the context of training, gets in the way of people being able to learn the actual training content. This video series only covers some of the basic concepts. You can learn more in our upcoming VR training design course. But what's interesting to me is that these mental models can vary by region or country. And this is why we need to think about internationalization for VR training design, especially if we're planning to release to an international audience. A great example that I like to give for internationalization is of the Sony PlayStation controller. They use symbols for their buttons instead of English letters, and this is a brilliant design when you're considering an international audience with varied writing systems. The problem you run into is when you get into the meanings of the symbols depending on the country, which as a side point is one of the main reasons it's a standard UX best practice to always accompany symbols or icons with labels in your UI designs. But back to the main point. In the United States, the circle button is generally used as the back button in menu systems, and the X is for selection. However, in Japan, they're reversed. The X is the back button, and the circle is the select button. It's the exact same controller, but different functionality for the X and the circle. But then with the release of the PlayStation 5, Sony announced that they were switching the functionality in Japan to match the rest of the world. This created a huge amount of backlash from the Japanese user base because of the confusion it would cause. And it was even more confusing for them because it only applied to the system interfaces. The games themselves didn't change. So your button functionality would switch depending on what you were doing. And that caused a lot of unnecessary misclicks and accidental interactions. And this also happens for games that are imported from Japan into other regions. The buttons for the same interactions change depending on which UI you're interacting with. Since our muscle memory and mental models get used to certain interaction patterns, when they suddenly change, it takes an extra level of cognitive load to make the change. In the meantime, a lot of accidental and preventable interactions are happening. It creates a significant amount of cognitive load because your muscle memory is so deeply ingrained, especially if you play a lot of games. Your fingers just react automatically. For those of you that don't game, think about when you touch type on a keyboard. And then when you switch to a keyboard that you're not used to where the buttons are slightly rearranged. Imagine having to constantly switch back and forth between those button configurations depending on what screen or software you're using. Or those of you that switch between Mac and PC at work might also understand. In gaming or in VR, that's more than just a minor annoyance. Where muscle memory and reflex matter even more, it's a huge frustration. You have to constantly fight your own muscle reflexes, and that adds this huge unnecessary mental workload. And you can easily make mistakes because your hand reacts faster than your brain can translate. This is another reason we need to do that upfront research on our target audience. How will these types of foundational design decisions affect your target audience? You won't know until you do the research. But one thing that we can apply to VR regardless of our target audience goes back to the principle of consistency. When VR training experiences don't use the standard button mappings for the headset, that can cause confusion and accidental misclicks and unintended interactions. That happens all the time in VR. For example, one VR experience might use the trigger button on the controller to grab items, whereas another experience might use the grip button. And there are reasons for that we don't have time to get into, usually because they're training across platforms or controllers. You want to use the standard button mapping for any specific VR platform's controller and headset so that you're not causing unnecessary frustration and cognitive load. Don't just create one set of mappings and hope it works for all the other ones. Just saying everyone else does it is not a good excuse. You can't control what everyone else out there is doing, but you can control what you do. You also want to make sure the tooltips match the controllers being used. This is even more important if you're releasing your experience on multiple headsets or platforms. I feel like I'm picking on Car Mechanic Simulator right now, but they give a really good example of how this can be an issue. Their game settings show that they support multiple controllers in addition to keyboard and mouse. However, their tooltips are only for keyboard and mouse and Xbox controllers. For those that don't know, on the Steam platform, which works on multiple devices including the PC, you can use many different types of controllers. The most common are Xbox and PlayStation. Xbox controller buttons have the letters A, B, X, and Y. But if you're using a PlayStation controller, which uses shapes, you're constantly having to translate that in your head. Okay, it says A, so I think that means X for my controller. And you're doing that every single time. And that can be exhausting mentally and annoying. So in the case of training, that takes your mental processing away from what you're supposed to be learning. It seems like such a small detail, but it makes a massive difference to the experience and their ability to focus on what they actually need to learn. These seemingly tiny design choices, especially across cultures, can dramatically impact how easily people can interact with your experience. It's not just what you see, it's what you expect based on years of ingrained mental models and muscle memory. So if this is a problem when you can see the controller in your hands, it's exponentially worse when you can't see the controller in your hands. First of all, you can't see your real-life physical controllers in VR unless they're digitally emulated into the virtual space. And then the real problem comes in when the wrong controller is emulated, or no controller is emulated at all. And both of these situations happen all the time in VR. VR creators might make the assumptions that since they know the controller buttons without looking at them, everyone will know the controller buttons without looking at them. They either don't realize or they'll minimize the distraction and the negative impact this has on learning. So you want to think about this stuff up front when you're scoping your project, especially if you're creating for multiple headsets or platforms. If you're deploying a Steam or a PC-based version of VR training, you don't always have control over which headset or controllers people are going to use. So you have to plan for that. And when you deploy, warn them ahead of time if certain controllers or headsets are not supported. And that leads into what we'll be talking about next time, which is cross-platform design. In the meantime, check out my free Udemy courses to learn more of the foundational aspects of XR UX design. You can click on the screen right now to check out the full 43-hour VR training playlist. I hope you enjoyed this video. I'll see you in the next one.